fault tree analysis. Unraveling complexity, ensuring reliability. Hello maintenance folks and fellow industrialists. Let's explore the fascinating world of fault tree analysis, or FTA for short. If you're curious about how industries like aerospace, nuclear power, and manufacturing ensure their systems are as safe as possible, then stick around. This is the tool they use, and by the end of the video you'll have a solid understanding of how FTA works and why it's so crucial. Let's start by breaking down what fault tree analysis is. Imagine you're looking at a tree, well, sort of, but instead of branches and leaves, we're dealing with potential failures or faults and how they're connected. It's a top-down, deductive approach, which means we start with a big problem like a system failure and then break it down into smaller, more manageable pieces or causes. The goal here, to figure out what might go wrong before it actually does. Now, why does this matter? In complex systems like those in an industrial plant, a single failure can lead to a cascade of other issues. Think of it like dominoes. Once one piece falls, it can knock over the next and the next. That's where FTA comes in. By mapping out all the possible faults, we can identify the weak spots in a system before they become real problems. So how does fault tree analysis work? It's pretty straightforward, actually. You start with what's called a top event. This is your main problem, the thing you absolutely want to avoid, like a machine breakdown or a safety incident. From there, you draw branches downwards, identifying all the possible causes of this top event. These branches represent gates and events. Gates show how events combine to cause a fault, while events are the actual failures themselves. For example, let's say we're analyzing the failure of a power generator. Our top event is the generator not working. The next step is to ask, why might this happen? Maybe it's due to a mechanical failure, or perhaps an electrical issue, or even human error. Each of these possibilities becomes a branch in our fault tree. And here's where it gets interesting. You can keep breaking these down even further. If it's a mechanical failure, what caused that? A worn-out part? Lack of maintenance? Each answer adds another layer to the tree, giving you a detailed map of potential failures and their causes. But the real power of fault tree analysis lies in what you do with this information. Once you've identified all the possible faults, you can prioritize them. Which ones are most likely to happen? Which ones would have the biggest impact? This helps you focus your resources where they're needed most, whether it's through preventive maintenance, design changes, or training your team. Now, you might be wondering, how does FTA fit into Industry 4.0 and the world of IoT? Great question. As our industrial systems become more connected and complex, tools like FTA are becoming even more critical. With IoT, we can collect real-time data from machines and systems, which feeds directly into our fault trees. This allows for dynamic, real-time analysis, so we're not just predicting potential faults, we're actively monitoring them and responding before they cause any issues. FTA isn't just a theoretical tool, it's practical, actionable, and when used correctly, it's a game changer in maintaining the safety and reliability of complex systems.